Testing, testing. Testing. Hello and welcome back to Human Resource Machine. I'm Acretio and let's see where we get today. So last time we got to year 18 and now I think I'm in unknown territory where I have never been before. Based on scrolling, I would say we are about little less than halfway through the game. Maybe we'll end it today, maybe one time more, but let's see. Constant. Let's see what this is about. Yes, welcome back. Thank you. Tick, tick, tick. Time keeps ticking down. Let's get to work. Oh, yes. I love what you've done with your hair. Thank you, thank you. For each number in the inbox, send that number to your outbox, followed by all numbers down to or up to 0. It's a countdown. We got new commands. They add 1 or subtract 1 from an item on the floor. The result is given back to you, and for your convenience, also written right back to the floor. Bam. Okay, so let's go inbox, outbox. Let's jump around. Jump from one to the other. Okay, the first question is followed by all numbers down to or up to 0. What does that mean? Does that mean that I should include 0 or that 0 should be removed? I don't know. But let's see. We have the inbox. Let's copy to spot 4 because we will use that. That's close to the output. We will run a lot between that spot and the output. Let's see, copy to 4 and then yeah, this is actually a bit tricky. Oh, let's put the outbox at the top and we can ignore that jump. We have another jump at the start that jumps to the inbox. The reason I'm doing this is that I can see that we will need to jump the outbox both for negative and positive numbers, and I think we have to handle them differently with the bump plus and bump minus. So copy to 4. Maybe not. I don't know. Let's see. Actually, let's not do that. Let's worry about one number. And then we worry about the loop. Inbox, copy to 4, we put it in the outbox. So 2, we put to number 4, we put it in the outbox. Great. Now, we have to check if that number is 0, then go back to the inbox. If it's not 0, let's say that it's positive, then we want to bump minus that and then go to the outbox. And once we have gotten there, we actually know bump minus, and then we go to the outbox there, and then we go through this all the way. So if it's 0, we go back to the inbox. If it's not 0, we bump minus and then jump up again. Okay, but what if it's negative? So if this outbox... Oh no, we can't do this. once we have the outbox, once we have the outbox, we actually, damn it. Once we have the outbox, we drop the number. We don't copy it to the outbox. We drop, so we don't really know how it should be handled. Yeah, this is actually a little bit tricky, but let's copy to 4. After we have copied to 4, oh yeah, let's do that after the outbox. Copy from 4. Then we get the number. Then we can see if it's 0, we go back to grabbing the next number from the inbox. If it's positive, we go here. If it's negative, oh yeah, if it's negative, we go there. We do bump plus number 4, and then we jump to the outbox. Let's see if this works. 2, put that number 4 there, grab that. Yeah, positive, grab that, it's positive. Let's add 0, 0, let's throw it away. -4, yeah. That's -3. I don't think I have optimized this fully. There's sure to be some things that's not optimized. But it kind of works. 0. Don't really like how he walks, but that's another thing. Two, 1, and then he should get 0. Yeah, 10 of your commands. I should have that one, but I don't think I have the speed challenge. Not even close. I don't know what happens if I press back. So let's continue to the elevator and then go back into it. Because I do definitely want the amount of steps as well. And I think by doing this, going in a lot of loops, I didn't get the steps as well as I could have. Or rather, not that, but the copy from over here makes it 1 extra step for each number. Let's basically start off, and yeah, that's possible. So inbox, outbox. Inbox, if 0, jump to the outbox. If it's negative, jump to over here, and then we... So yeah, if it's 0, we don't even have to store it, we just put it in the outbox. And then we go back, yeah, I should add that. Then we go back to the start. If it's negative, we need to copy it to, let's take number 9 space. Let's see if he doesn't, see if he walks this strange way or whatever happens now. But let's copy it to number 9. We already know it's negative. So copy to number 9, bump plus number 9. No, don't do that. Copy to number 9. No, actually, if it's not 0, then we copy to number 9. No matter if it's positive or negative, we want it at that space. If it's negative, we want it at that place and we want it to the outbox. If it's negative, we want to bump number 9, and then place it in the outbox. And then we jump back to check if it's negative. If I go up here, we have a lot of extra copies again. That's what I want to avoid. Okay, bump that, and then if it's 0 at that place, then we jump to this outbox to stop the loop. But we still put the 0 on the belt, and then jump to the exit. If it's not 0, that means it's still negative. We want to jump from here, and then we bump it, check if it's 0 on the outbox, and do that all the way through. Okay, so there we have if it's negative. If it's not negative, if it's positive, then we want to do the exact same thing, but decrease it instead of increase it. So decrease 9, jump F0 to wherever that was. Let's go there. Outbox, and then jump back to the decrease. Do we have a loop around everything? Yes, we do. This is awful code. Don't do this. But it might be the fewest steps to make. Oh. That makes perfect sense. Don't jump if negative with empty hands. This is what happens if you make bad code. So the problem is that we put it to the outbox. If it's 0, we got it down. If it's not 0, we copy to the 9, we put it in the outbox. Actually, this is wrong. If it's not 0, we know it should always be copied. But to get as few steps as possible, I think it's smarter to have the copy to as part of the loop, isn't it? Let's try. Let's after this outbox, copy from number 9 and see what happens. I think the code should work, but yeah, we did one step extra with copy from. I think that will make it so that we don't get all the points we could have got. Jump to the start. I like this way of walking better. We don't do this strange walking around. Zero, we just put it there. -2, yeah. This is the step. We grab the number. This should be, I think, 3 steps more than is needed, which should make us fail this challenge. The speed challenge, that is. Yeah. 85 instead of 82. So let's go back. Let's fix that by not having the copy from, and if we don't have that, we need to put the copy to within if it's negative or positive. But that should go before the jump back with the loop. Copy to directly below this. Copy to 9 and outbox. This should work. And we don't have to pick it up again. We just get there. we already know that it's positive or negative, but positive in this case. And we don't have to worry about it, but yeah. This should be the lowest amount of stats, I think. But the code is off. To be honest, code that jumps around this way is awful no matter what you do, so don't do that. If you have to do it, don't write this code at least. So let's see. Way too many is too large size. But the speed challenge was okay, so we got both of them. Now let's go to the multiplication workshop. Year 20. Seems like only yesterday we were learning about adding fond memories. We worked so hard back then. For each two things in the inbox, multiply them and outbox the result. Don't worry about negative numbers for now. You got labels. They can help you remember the purpose of each line on the floor. Just tap any tile on the floor to edit it. Okay. Okay. Now I see the problem. Yeah. So we should multiply, but we don't have any way of doing that straightforward. So we basically need to count down. So if we go for copy from 0, copy to hello. Let's get rid of all of that. We have the clear button. Inbox to outbox and get all of the numbers. That's the basis. So when we got in the inbox, let's copy that to space 0. Yeah, that's fine. And then let's get the second number in the inbox. So now we have the 8 over here and the 4 over here. I think let's copy that to number 1. The thing is, as the numbers are placed, we always have the bigger number, smaller number, bigger number, smaller number, bigger number, smaller number. So it's more efficient taking the bigger number and add that together the smaller number amount of times. So let's try to do that. So now we have the... Yeah, maybe we should do this. Big. Small. So then we have the bigger number, we have the smaller number, and now we have to add the bigger number together the smaller number amount of times. And we do hold the smaller number. So let's think. Let's think. Let's have that as well. Current. This is the current calculation. Before we start, actually the current calculation is 0. So before we start grabbing from the inbox, copy from 0, copy to current. Great. Then we grab the big number and we grab the small number. What do we do now? Oh yeah. Okay, if we copy from the smaller number. Yeah, this seems strange with copy to and then copy from, but I think we can make it smarter, but I think it will make sense. No. Yes, copy from the smaller number. If the smaller number is 0, then we want to copy from the current number and go to the output. No, that's if it is 0. Whoops. So if we shouldn't add it together anymore, we want to grab this number, put it to the value. Okay, so that's a 0. So what if this small number is not 0? If it's not 0, we do bump minus, small number, and we go to say copy from current and add big number, copy to current number. And once we have done this, we know that we have checked one number off, and we should go up here again. Copy from the small, check everything, and so on. I think this will work, but I'm not sure. Not at all. So grab that, put it in current, grab the 8, the big number, the 4 to the small number. Yep. It's bigger. Let's add another 8. It's bigger. Let's add another 8. I think I have made a mistake. Oh no, 7. That's 32. That's 0. Let's grab that and put it in the outbox. And then we do it again. Let's have a look at this one. We have an 8 in the big, have a 0 at the small. To 0, let's grab the current right away. Let's reset the current. 0 for the big, 2 for the small. Yep, we are adding 0 to 0 2 times. Okay, that's totally fair. Let's see what the rating says about this. Okay, this is a lot of steps. I mean, I could have chosen to get the big or small either way. So grab from the big and count on the small, or grab from the small and count on the big. It would be the same. Oh no! The speed challenge I knew I wouldn't make with this one. The size challenge I thought I would make. But we can remove one. Remove one command. What command can we remove? What command can we remove? We need to grab from both of them. We need, I think, place both of them down. Or do we? I think so. I think so. Oh! What is it? I was thinking we could remove this copy from current, because we get from here. Copy to current, then we already have it, then we don't need to copy from it again. But what happens if we come from this point instead? Then we have the small. Is that a problem? Yeah, if small is 0 but have been greater, then we don't want to copy from current. Then we need to copy from current. Ooh, this is actually kind of tricky. Copy from 0, copy to current. Let's see, we don't have any way to check numbers. I mean, there is a chance. Yeah, maybe that actually. There is a chance. There's a chance that instead of checking if it's 0, we could decrease it first and then check if it's negative. What will that do? Will that make any difference? Copy too small. Let's decrease the small. I still need to do that in the loop. Decrease small. Then we actually have the small. We don't have to copy from it. And jump if negative. We jump down here. We remove this one. So if that's negative, we will get here, copy from current. If it's not negative, we will copy from current, we will add everything. I think this should work. And then that should improve the amount of arguments, of commands to use. Let's go a little bit fast. Just see if the first calculation is correct. Then we go full speed. Yes. Full speed. Yeah, I can't see anything either. A lot of things happening. Yep. And this should be the size challenge completed, yes. But the speed challenge, we're way off. Way off. Let's go back. Let's try to get the speed challenge instead. There we have the clear. Yeah. So we don't have any way to see which of these are higher. Which of the two numbers are higher. So that's fair. Well, we do. We actually do. But we don't have a straightforward way. Let's grab the inbox, copy to the big number. Let's grab inbox, copy to a small number. No, I'm gonna say that these are not necessarily big and small. I want to figure out which one is big and which one is small. So we have the small number. Let's subtract the big number. So small minus big. If this is negative, we know that small minus big, so 4 minus 8, that's negative. If that's negative, we know that okay, let's change this. It's not small and big. This is number B. Okay, and this is number A. It was confusing me. So now we have number A and number B. If we take number B minus number A, and that's negative, then we know that B is the big one. B is big. Okay, if we don't get negative, we know that A is the big one. I was about to make a note saying that the small is the big one, but that would just have been confusing. So, let's say that A is the big one. Then we basically want what we had before. Why did I delete that? Oh well. So, copy from A. No. No. Bump minus B. If that is negative. The advantage with this is that we both pick it up and we decrease it at the same time. That's negative. Let's go to the outpost. Oh, let's do this. No, let's not go to the outpost. Let's copy from current and put that to the outpost. And when we start a new round, we want 0 to the current. So here we go, copy from A and copy to current. Okay. So now, if A is bigger, we decrease B. If B is negative, then we know that we actually have the result already. Copy from current to the outbox. If it's not negative, then we know we want to add A and current. So copy from current, add A, and copy to current. And then we jump. Where do we jump? We jump to the start of this loop. So we still know that A is the big one. Okay. So now we do the same if B is the big one, but we change this to bump plus A. So, no. Bump minus still, but A. So we want to do the same, but we change the B to A's and the A to B's. Jump if negative. It's that one that goes all the way here. Great. If it's not negative, that means we should add once more from current. B, copy to current, and then we jump to here. Yeah, let's see if this works. I think it will work, but I don't know if it's the least amount of steps we can use. It's possible we can do some statements saying that if A or B is 0, then we get fewer steps or something like that. So this is where we have B as the big one. Wait. B is not the big one. Stop this. Stop this. This is wrong. This is wrong. In that case, A was the big one. Let's run this slowly again. Replace the 0. That's great. We get that, place it there. Get that, place it there. We subtract that and figure out that A is the big one. Yeah, this have been messed up. So if I have B, if I have 3 and subtract A, should have a negative, and then A is the big one. Yeah, so basically I have messed up which one is the big one. Just needed to move everything. Unfortunately we don't have if positive. That would have been easier, but let's do it this way instead. Get this, should go down here, copy from current, add A, copy to current, and then we have to jump. That doesn't make sense right now. That should jump to here. A is the big one, and if negative, we should jump here. That should work. Let's hope that it works. Why didn't I run it through? Check that it actually worked. Yep. Okay, so now it's adding the big numbers instead. That's great. That's kind of what we want to see. Now, is this possible to make in fewer steps? Yes, probably. But I don't know how. So let's hope we don't have to do that. Yeah, and now we are adding the B. This should hopefully work fine. Let's see what happens with the zeros. Oh, we have the 5. Yeah, there's a few steps. If that is if any of the numbers are 0, that we might be able to remove, but I don't know if that will improve anything. Let's see where we get first. Maybe we are not even close to a good solution. Who knows? Oh, I think I found one problem. Speed challenge 125 instead of 109. Let's go back. When we have filled everything in, we still copy from 0 and copy to current. That happens before we go to the inbox, so we do that at the end. If we move that to do that after we have grabbed the first number, it won't do that at the end. Let's very quickly run through the simulation. I didn't take note of the numbers. I just want to see what numbers we get. I don't even know if it's the same numbers every time. But let's see. Maybe it is, maybe it isn't. So, in the size we don't care. Yeah, it seems to be, I think it was 109 before. But yeah, we have 120, 109 in total. We got 125 steps. If we move these down, let's run it again and see what happens. From 125, I think we should get 123 instead. That should make a difference on those two. We still have a long way to go, don't get me wrong. But at least we have the first things, the first problems. Yes, no, it's 123. Okay, so we still need to remove 14 steps. That's a lot of steps, actually. So how do we do that? Can we remove any jumps? So this is to set everything up. We set up the A, we set up the B, we set up the 0. And we check which one of these are larger. So I don't think we can remove anything here. Don't remove this jump. Okay, so next thing we can do, if we go to minus A, if that's negative, we go here, we copy from current to the outbox. That seems okay to me. Negative if 0 jump, plus minus sub, add copy. Okay, we bump that. If that's negative, we grab the current and place it. Otherwise, copy. Copy from current, we add B, copy to current. And we do this all again. And we do the same over here. And we have taken, we have checked that we get the least amount of loops in this with the A big and the B big stuff. So we don't add 4 9 times or 3 7 times. It costs a few steps in the beginning to do that. Well, I think it costs like the sub and the jump. But that should be okay. Or even if it isn't, it shouldn't be 14 steps that could be removed. What do we have? 1, 2, 3. I think 5 pairs of numbers. I mean, in theory, we could remove this jump and move the copy from and out box. Place them here somewhere. Yes, somewhere else, but we have one jump for them, so I don't think that's a problem. What if we use the jump if negative instead? Wasn't that what we checked with the last puzzle? If we use the jump if 0 instead, then we got one more thing because we had to read a number. Yeah, that's it. Is there a way? What could it be? What could be the problem? I'm thinking, is there a good way to add 2 times? If we add it 2 times, then we need to check if B is, or in this case, if A is 0 or if it's negative. If it's negative, we add it to, no, oh yeah, if it's negative, we jump to the top. If it's 0, we add 1 time. If it's positive, we add 2 times. Let's try that. Let's try that. If it's negative, we jump to the top. If it's 0, do what we have done now. We add it once. But if it's not 0, then we copy from current. We add B. Add B. And we copy to current. And then we have that loop done. So we jump to big, to B again. Let's run this and see what happens. Of course, since we haven't done it with A big, we have just done it with B big, it won't solve everything, but we had 123 last time. So this is A big, that didn't change. Let's run through that a little bit quickly. Now we have B big. So we add it twice. Oh, no. No, this doesn't work. It will get the wrong result. I forgot that if we do this with positive, we have to bump A minus twice. Yeah. Management expected 36, but your outbox 63. Well, just turn it upside down then. No, this is, yeah, that was a mistake. If it's positive, we add 2, but that means we have to decrease this 2 times and not just 1. So let's bump A minus to start with. And then let's run it again. Now we have kind of seen that it works. Not if it works the way we want to, but that it kind of works. So let's see. 123 we got the last time. Is this any better? It should be. Well, not a size challenge. It's not. 117. That's like 6 lower. So go back. Let's do this for A big as well. Okay, so if 0, we jump here. No, be down here. If it's 0, jump there, and we bump B minus, B, okay. Copy from current, and add A, yep, add A, and copy to current. Okay. Oh, and then we have the loop, of course. We need to jump here. Yeah, let's see what happens. I think it will work. I think it will be just above what we need. So we need to improve the number of steps once more. This is definitely a step up in difficulty. Yeah, 37 commands to get 111 steps instead of the 123 we had before. Or I think it was 160 when we had 15 steps. 2 steps we need to remove. Steps, it's not. It's steps, it's not rows. So we can't just cram the copy 2 together or anything like that. That might be an idea, actually. To have those copy 2 after the jump. We could actually have one of the add A's after the jump as well. But that would decrease the number of rows, but not the number of steps. So let's not do that actually. I kinda want to do it anyway. Wait, one thing I'm thinking about. What about the zeros? The zeros over here. What if we check them right away? Have this copy to B, sub A, and then we grab the A again, which is not a problem, but we can copy from 0 and copy to current. We can do that after we have read everything from the inbox. Let's do that. Let's see, inbox. Since we're multiplying, if we have a 0, we want to go to the outbox. No. If we have a 0 on the second digit, we want to go to the outbox. But if we have 0 on the first digit, we still need to get rid of the second digit. So if we have a 0 on the first digit, we go here. Nothing is run over here. So what we do is read the inbox. Is this right? Yeah, it might be. Let's get rid of that. Let's see if this solves it. Just with checking after the second input. It might worsen the situation, but it might also solve it. Okay. Now, with this, we should go directly to the belt. And that might be it. The thing is, we will still do the calculations here. That's just a small amount of steps. I don't know if it will benefit anything doing that the other way, because we need so many steps to do it. It would still be fewer steps than walking through the normal stuff. Let's see what happens. 109. Okay, 130. 130? How could this? Could that add that many steps? Let's remove it and run it just to check. That should add like 10 steps, and then remove a few steps. Well, you remove a few steps when it is 0. Something seems to be a little bit off. And it's probably me, but yeah. Thought we would just okay, so now we have a lot of steps again. What have happened? We were down to 111 steps. Yeah, we moved those. Okay, let's move those back. Here. And let's see how many steps we get now. We were down to 111 steps, and now we're up to 150 something. Something is not the way I want it to be. Okay, so now we have 111 steps. Let's run it once more without any changes, just to make sure we have 111 steps all the time. Let's actually run it a couple of times, just to make sure. Yeah, the amount of commands, that's way above what we want. Okay, and let's run through it all again. And let's see what we get. $111 steps. Now, let's move that down, move this down. We haven't changed any loop. We haven't changed... We haven't changed it out of the current loop, out into... Oh no! This doesn't work. How did it ever work, actually? Now we are jumping based on the 0. So we are always doing it one way. Okay. That's why it didn't work as I expected it. But it works the way it should. Okay, so this is fine. Let's add this again. If the second inbox is 0, we jump right to the outbox and then we read the next number. Let's see if we increase or decrease the amount of steps we take with that. I think we will increase it a little bit, to be honest, because we do that every time, and the amount of times it's a 0 is not that many. Oh, it's actually 109 steps instead of 110. So maybe, just maybe, that's what we should do with the first inbox as well. Jump if 0, we jump up here. We grab whatever is in the inbox, which is the second number. We don't care about that number, we just want to get rid of it. Then we copy from the 0. And since we don't want an extra loop, we go to the outbox. And then we jump to first inbox again. Maybe this works. While this is running, I will go and grab some water. I forgot about that when I started this. Let's see if I can mute my microphone. So I'll just mute my microphone and I'll be back in a minute. Yeah, so that seemed to be working fine. Let's see if it actually did something. We got us down to the 109 we need. This is really crazy. I mean, if you ever need to do something like this, make sure to get a multiplication function instead, and then you don't have to worry that much about it. But as a game, it's fun. I've already been at this 107 steps instead of 109. Yes, it worked. This shouldn't have worked, but okay, fair. Okay. Only done 2 levels and it's taken an hour? That's crazy. Let's do 1 level more at least. Fibonacci this. The difficulty curve have definitely ramped up. This back hallway is for advanced employees only. I've solved everything this far. I'm advanced, I think. Are you sure you want to be here? No? These night shift assignments are optional, you know. Well, have to do that, right? And they are difficult. Maybe. If you need to ask for help, I'll just be here looking through these catalogs for Golden Spiral. For each thing in the outbox, in the inbox. Send to the outbox the full Fibonacci sequence up to, but not exceeding that value. For example, if inbox is 10, outbox should be 1, 1, 2, 3, 5, 8. What's the Fibonacci sequence? Ask your boss or a friendly search box. So, the Fibonacci sequence is, as it is here, it starts with 1, 1, then the next number adds those numbers, so that's 2. Next number adds the previous two numbers, 1 and 2, that's 3. Add the last two numbers, 2 and 3, that's 5. Add 3 and 5, that's 8, and so on. Okay, so let's set this up. We still have no way of seeing if a number is greater than something else. Let's first set up the 1, 1, I think. Yeah, let's use space. Oh. That's the first digit, that's the second digit, and that's the sum of those digits. So, to start with, let's copy from 0. Let's copy 2, 1. Let's bump 1, that digit, and let's copy to number 2. Let's also outbox what we have. So now we have outboxed what we have in 1. The next step, yeah, we have that set up. We have one more thing to set up, and that's to grab from the inbox and copy that to the first available space, I think. So now we have all the numbers available. Now we want to see if 2, whatever digit we have at number 2 is larger than, this is the max. And this max is the number we grabbed from here. So if the number we have in number 2 is greater than the number we have in max, then we stop. If it's not, we want to make a sum. No, we want to copy number 2 to the belt. We want to make a sum. Is this the right way of doing it? Yeah, let's go for that. If this number is smaller than the max, we want to put it on the belt, sum those two numbers, and then move them to the left. Okay, so now we have max, and we actually hold the max number. So from the max, if we For each inbox, send to the outbox the full Fibonacci sequence up to but not exceeding that value. For example, if inbox is 10, outbox should be 1, 1, 2, 3, 5, 8. What's a Fibonacci sequence? Ask your boss or a friendly search box. Yeah, let's start with actually getting the inbox and copy to max. Then we have that number over here, and then we set everything else up. And then we have a 1 in the outbox. The reason for that is that I think we need to take the 2. We need to take the 2 minus the max. And then check if that's negative. Is that correct? If this is 21, and we take that minus, if this is 1, and we take that minus, which way is it? If we take 19 minus 2 minus the number in place 2, 19 minus 1, that's positive, we should place. 19 minus 20, that's negative, we should not place. Okay, I'm changing my we want to grab the number we have in max and subtract what we have in 2. Negative, we want to start off with the next number. Oh. Okay. Never mind, we want the inbox to go first, simply to stop it as soon as possible. That means we have a copy from max. Sub what we have in 2. If it's negative, we go to the next number. If it's not negative, we go and copy from number 2 to the output. And then we want to add 1 and 2, place it in the sum. Add 1. No. Copy from 1. Add 2. Oh, no. Whoops. Okay. Don't know what happened. Add 2. And copy to sum. And then we have a lot of copy to do to move it to the left. So copy from 2, copy to 1, copy from sum. Oops. Copy to 2, set it up for the next one. We don't care, this is wrong, that doesn't matter. And then when we do the loop, we can do it up here. Yeah. Then we... What? I think there's some problems with my mouse. That's okay. Let's see if this works. Get 19, get 1, we add to that, we place that in number 2, and we add it to the output there. That's positive. Let's add number 2 to the belt. Let's add those two together, place in the sum. This is wrong. This should be in a 1. Yep, exactly. Stop and reset. When we have copy to sum, then we have to take copy from 2. Then we put that back. Copy from sum, copy to 2. Yeah, let's run again. One. That's positive. Let's put the number 2 in box. Let's add 1 and 2. Place to the 2. Let's move everything a step to the left. And let's check if the number 2 is bigger than 10. It's not, so let's add them. Let's add it to the sum. Let's move them around. Here we go. I think I know one optimization I can do. Instead of moving everything before checking against that, I could keep it in the sum and then move it everything a step to the left once I know that it should be moved. Once I know it should be calculated another step. So let's place 2 1s at once in the output and then place the sum. Yeah. Oh yeah, but let's get this going a little bit faster. It should be fine. The technical part of it is okay. Commands, yeah. One more command. Oh! I was way closer to the speed challenge than I thought that was. Let's see, what command can we remove then? I think we always needed to do the sum. So we shouldn't be too hung up by that. Okay, so we copy from max, we set that. Copy from 0. Set it to 1, we bump that. Copy the same to number 2 and place it in the output. What should we optimize first? Let's do the amount of steps. I can't really see how we can do this in fewer steps. No, not fewer steps, fewer rows. Fewer rows. Then we copy from max, we check against the number 2. That's negative. If that's negative, we are done and we start over. If that's positive, we copy from 2 to the outbox. Wait one second. It seems we can do something here. No, I don't think we can. I was thinking about 2 and the 2, I think. We do have this outbox, but that's the digit that starts in number 1. Oh, wait. Wait one second. For this, first, to minimize the amount of rows, we don't have to do that. We could have a 0 there to start. Then we don't need this outbox. Copy to 1, copy to 2, bump number 2, and then we don't put it in the outbox. Then we have 0, 1, we don't have a sum, but then we go through all of the steps to get 1, 1, 1, basically. Yeah, that should be it for getting the fewest amount of rows. Yeah. I'm not worried about the mathematics of it, that's the thing. It's the code to get it to work that's... Oh. Let's see, we have number 3, number 5, number 8, 13. No, let's go slow. Copy from that, add 21, and then we move everything around. I think if we don't move everything around, we just use the sum, we could lower the amount of steps. But let's first get the amount of rows, or commands, if they want to call it that. 19 commands, 183 steps. That seems fair enough. So yeah, now let's worry about the sum. But we could do the same with the sum, can't we? Bump number 2, then copy to sum. And instead of sub 2, we take sub sum, remove that. And if that's negative, we are done with that loop. Otherwise, we want to copy from sum, go that, paste that in the outbox, then add 1 and 2 to the sum. And then all of this copy is in the beginning of the loop instead of the end of it. Not really. Copy from max, sub sum, jump if negative. Copy from sum to the outbox. But after we have placed it in the outbox, we want to calculate the new sum, and then we need to do all of this. Yeah. Copy from 2 to 1, copy from sum to 2, and then no. Then we have... Wait, copy from sum to 2. So we already have the number 2. So let's add number 1 to it and copy to the sum. Okay, this should increase or decrease or whatever it is. It should make it fewer steps. But management expected 1, but the outbox 2. Okay, I did not expect this. Let's stop and see what happens. Let's actually run it again. 7 over there, that's fair. 0, increase that, replace that as the sum. Check, that's 6, replace the sum. Remove everything, check the sum. Paste that. Paste the sum. Oh, yeah. That's true. That's true. I forgot that when I do this, I have the sum. I should have 2 1s. So I should go to the outbox after copying to the sum the first time. Since this digit is never added to the outbox. So I think the calculation works. It's just the initial digit didn't work. Looking good this far. Either way, 9 is the same as 10 when we're talking about Fibonacci, but 21 is not the same as 20. 21 means I have to do one more calculation. Let's see what happens. It might be that I have to break it down and oh! This worked. Okay, fair. Let's not make it harder than this then. I was thinking I might have to break it down and actually do the Fibonacci sequence and calculate it step by step and add more boxes and then just check it, doing everything without any loops. But we should definitely use loops. 1.5 hours. Let's do one more. Mod module. How many hours of work can you fit in one day? Not enough. There's always a set remainder of unworked hours. Good thing we have this optional night shift to cram in more. Well, if you say so. For each 2 things in the inbox, outbox the remainder what would result if you have divided the first by the second. Don't worry, you don't actually have to divide, and don't worry about negative numbers for now. Okay. Divide the first by the second. So it's the remainder. Inbox. Let's place that in slot 2. No. Let's place that in slot 4. Then it's more forwards, backwards. Don't have to walk up and down that much. Then inbox, copy to slot 3. Okay. So what we want to do now is to decrease box 2. No, we have box 2. We want to decrease box 3 until we get negative number. When we get negative number, we want to grab that. Okay, so copy from, this is the setup, copy from number 2, subtract number 3, negative, let's put it at the top, just because we want to. Copy from box 2 and go to the outbox. And let's make sure we don't get that as the first thing. If it's positive, we want to loop this. So copy from 2, sub what we have in number 3, and that should be it, I think. Oh. Except that I messed up which values I was using. Okay, that should not be 2 and 3, it should be 4 and 5. So wherever we have number 3, it should be number 5. Rid of that. Wherever it's 2, it should be 4. Copy from 4. Copy from 4. Subtract 5. Okay, what about now? Isn't it nice with programming, where you can actually test things and you don't have to worry too much about it? I'm stuck in an infinite loop, damn it! Let's see what it says. Does it ever stop, or does it just go on forever? Oh, it just goes on forever. Okay. The problem is that this value should have copied to... No, it should not. I don't need to... I actually don't need to copy from number 4 again. If I just subtract whatever in box 5, and then if it's negative, I add what's in box 5 instead, and then go to the outbox. Then I revert the last thing I removed. So if it's negative, it goes up there. If it's positive, it subtracts. So it just subtracts until it's negative, and then it adds 1 back. Oh. No. Yes. Let's have a look at this one. 4 minus 7, that's 3. Let's add 7 again, and that goes up 4. 0, 7, minus 7. Let's add that back, and I think that should actually solve the full challenge. Just 12 or fewer commands. Yeah, 11 commands, 57 steps. I did it in 50. Yeah, this is actually great. Oh, the problem with that is that now I want to do another challenge, but I've already been on this for 1.5 hours, and the first 1, 2, 3 challenges today took half an hour each. This was very quick. Nah, let's not do another challenge actually. Let's instead accept that, yeah, this is it for today. thank you so much for watching, and see you back another time. Bye!